Hi, my name is Ayush Maniar. I am a master's student at the University of California, San Diego, and I have been working on this fun project for visualizing the recipes of Minecraft items as a directed graph of nodes. And you can see a quick example of it over here. I can just select cyan concrete powder, and to build 8 cyan concrete powder, you require 4 sand, 4 gravel, and 1 cyan dye. For building the cyan dye, you in turn require blue dye plus green dye, and for building the blue dye, you require a lapis lazuli. And this is how the entire recursive graph can be displayed for any item in the world. So we can take wooden pickaxe for example, and we can see that for building the wooden pickaxe we need 3 oak planks, we need 2 sticks, and for building the sticks we in turn need 2 oak planks, and for building the oak planks we need 1 oak log. So that's how this entire project is structured. And if you want to follow through the actual code of the project and how we can build such projects with the help of Streamlit in a matter of hours with the help of Claude and ChatGPT, then follow along through the video. So let's see how we can download the images of all the items in Minecraft programmatically. So for that, we will use the help of Minecraft Wiki, which has details of all the items in the world, right? So what you can do is that you can just click on any item, like say crossbow for example, and you will be able to see this small image of a crossbow over here. And if you right click on it and open the image in a new tab, then you would be able to see that the image will get opened at this URL called invicon underscore crossbow.png, and then there are some random bytes after that. But even if we remove those bytes and press enter again, then we would still be able to land on the same page. And this thing is true for all the items. For any items, what we can do is we can just go to the page, we can right click, we can open image in new tab, and we would see invicon underscore gold.png. For the spyglass, we would be able to see something like invicon underscore spyglass.png. So now that we know the URLs, we need to iterate through all the items in Minecraft world, and for that we are going to leverage this library called Minecraft data. And we would have to do slight amount of reformatting to match the naming format of the items stored in Minecraft data library to the uppercase and underscore formatting that is present in the URLs. And then once we know the URL, we can just save the data. However, it's not that straightforward, because if I was trying to download the data from these URLs directly, then I was getting a lot of security errors because Minecraft Wiki was blocking a lot of automatic requests. But for that, I use this library called Puppeteer, which sort of simulates a local browser running on your local laptop, and then iteratively goes through all the different URLs and saves the data scraped from those URLs in a particular folder called Minecraft images. So let's see how this actually works. I can just run this node download items.images .js, and what would happen is that iteratively it will go through all the items and start saving the data. And this all happens in a Chromium browser, which is sort of a simulated, sort of a fake browser on which these things run. And you can go to the main folder, go in the Minecraft item images folder, and you will be able to see all the images getting stored iteratively. And you can click on any image like calcite.png and you will be able to see it over here. So yeah, that is how we do the first step of downloading the images of all the items programmatically. So now that we have the images of all the items stored with us, what we need now is the recipes for the crafting of each and every item. And in order to get that, we would be again using this library called Minecraft data. But on top of that, there is this wrapper which is inside the Minecraft GitHub repository. If you go into source utils, you will see this file called mcdata.js, which has a lot of useful wrapper functions on top of the Minecraft data module, which we can use. And I am just saving the recipes for all the items inside this particular JS file, and I can just run this, and I will get a JSON file which is called recipes.json. So let's take a look at that. Now if you see recipe.json, what you will be able to find is that for each and every item we have the ingredients and we have the crafted count. So I can search something like stick, and I can get that if you want to craft sticks, you need 2 oak planks, and upon merging these 2 oak planks, you will get 4 sticks. For another example, I can take something like, say, diamond sword, and the recipe of the diamond sword is that upon mixing 2 diamonds and 1 stick, you get 1 diamond sword, right? So just like this, as you can see, this is a very huge file with recipes for all the items. Some items like, say, oak log are considered a base item which have no ingredients, and they would be treated accordingly. But the thing is that this all is again in the form of JSON data, right? These are not structured as some kind of adjacency list or some kind of a node and linked objects inside some JSON directory. So we still don't know how exactly the graph will be formed using these recipes, and for that I'm using this Python this Python code which converts and formats our recipes.json uh, recipes into edges and nodes. So let me just run this. And what you will get is another JSON file called graph.json, which will have, first it will have the list of nodes. So it will have the list of all nodes, and then we will have a list of links or a list of edges which have the information about the which have the information about all the parents who are involved in the crafting of a particular item. So I can search something like target of stick target stick, and I can see that for the target of stick I have an edge which goes from the source of oak planks towards stick. The weight of this particular edge is 2 because we require 2 units, and the label stores the information of the number of parent ingredients required and the number of items that get crafted. So in this case we require 2 oak planks to make 4 sticks, so it is 2 cross 4. If we have a target of wooden pickaxe, then you would have something like this, where you have 2 edges going to the target of wooden pickaxe, one from oak planks and one from sticks, right? And now this is in the form of a graph, and we can now start working on the streamlit network app.py, which is over here, to actually build and visualize this graph. Yeah, so now that we have the images of all the items stored and we have the recipes in the format of a graph where we have nodes and edges, let's see how we can build a Streamlit app to visualize this graph or this network in a very beautiful way. And most of the code that I have written for this is with the help of AI, and this code is very generic. It's not specific for our use case of Minecraft item network and how they are connected to each other. Rather, it works for any graph for any network that you want it to work for. So first we will just load the images for all the 1312 nodes or the 1312 items that are there in Minecraft. We will load the actual graph.json file and store that in a networkx.digraph object, and then we just do the visualization. Funnily enough, the most of the time spent was in actually drawing the arrowheads inside the image, which shows which source points to which target, and that was what took the most of the time to debug and to get it correct iteratively. And now we can just run this. So let's do that. Let's run this. We can just call streamlit run network app.py, and what this will do is that it will try to load all the images. We can just go here, we can just select any network that we want. I will choose the graph.json file that we just created, and it will start loading all the images. As you can see, it is taking time to load all these 1312 image traces, but thankfully I have it running over here, and this is the graph that we get. As you can see, the Minecraft graph is way too messy. There are a lot of items which are interconnected with each other. It's almost like you can't even make anything out. Even if I zoom in using the Plotly's inbuilt features, then also I see so many items stacked together that I cannot make sense of it. But thankfully, we have a particular function inside our code which helps us see only the prerequisite nodes for every item. And let me explain what that is. What that is we traverse recursively backwards from the target item, the prerequisite item, and find all the parent ingredients that we need to craft it. So if I write over here something like wooden pickaxe, say wooden pickaxe, then what I would see is something is a much more readable graph like this, where you have wooden pickaxe, which requires 3 oak planks and 2 sticks. The sticks in turn require 2 oak planks to make 4 of them, and then the oak planks are made from the oak logs, and we get 4 oak planks from one single oak log. And as you can see, this is much more readable than the convoluted and messy full graph that we were seeing. And I think this is a very good way to visualize how complex and difficult it is to craft an item, depending on the number of prerequisites that are there for each item. Another example that I like is of a gray candle, because it has a lot of prerequisites. If you see here, let me go in the full screen mode. So we have gray candle, and for making the gray candle we require 1 candle and 1 gray dye. For making the candle we require string and a honeycomb, and for making the gray dye we require black dye and white dye, which in turn comes from a bone meal, which in turn comes from bones, and the black dye in turn comes from an ink sac. So as you can see, this is slightly more complicated item to craft as compared to something like a wooden pickaxe. And if we have some items like, say, oak log, then, well, this has 0 prerequisites. This is an item that you find out in the world. It has no crafting recipes, and it has a depth of 0. So yeah, that is it. That is how you can visualize the crafting recipes for each and every item in the world with the help of the streamlit app. Hope you liked it. Thank you.